also looked at several states in the process. So in chapter section 3.2, we are going to look at memory management. Okay, okay, we are going to look at memory management. Okay, so this is today is the 8th of December. We are doing 3.2, which is memory management. So we are going to look at what is memory itself. What do you mean by memory? Is there any? There are several types of memory. Where is it located, and how does the memory access data from the hard disk or anything else? All right. So and then in chapter 3.3, we are going to look at the input-output. Okay, so the first one, 3.1, is about the process. 3.2 is about the memory, and 3.3 is about the input-output. Okay, so let's start with what is memory first. So memory is a central operation of the modern computer. Memory refers to the physical devices used to store program, which is also called sequence of instruction, and or data, program state information on a temporary or permanent basis. Okay, so you have two kinds of memory here. One is the RAM, which is temporary, and one is the permanent, which is it can be the ROM or your hard disk. Okay, so it's referred to as a physical device, meaning it's a hardware physical device where it stores program and data, or stores information about any application or any program. So there are, in the memory hierarchy, basically there are two types of memory first: primary and secondary. The main difference between these two is the speed. Although yes, now we have secondary memory, which is way much faster, but in general, the RAM or the primary memory is always faster than the secondary memory, simply because of its location. Why is the location important? Because the location of the primary memory is very close to the CPU. Okay, so that is about the memory hierarchy. So basically, we say we have two types of main memory. Is divided into two, primary and secondary first. So when I refer to primary memory, I mean the RAM or the ROM. When I refer to secondary memory, it means the hard disk and thumb drive also. Okay, so main memory is volatile memory. It provides fast access. Okay, quite easy to understand. Secondary memory is non-volatile, meaning data can disappear, way much slower and cheaper than your main memory. So main memory, we are talking about your RAM only. Okay, your RAM and your ROM, sorry, your RAM, because it provides a volatile memory. Volatile means data can be, the information there will disappear when you off your PC. Okay, so that is main memory. Secondary memory, yes, is much more slower, but the main difference is the data would not disappear when you off the PC. Okay, so main memory is available for program plus data, may be insufficient. Okay, fine, but because of the size, it's insufficient. So what does the computer system do is they will use an overlay, because you have to remember each time a program needs to run, the program will go inside the main memory or your RAM to be processed by the CPU. So the CPU will only process programs that are from the main memory. However, main memory size can be limited. Okay, the size of it can be limited. So when the size is limited, the main memory only keeps data or information that is necessary at that point of time. line data will be kept inside the hard disk. And once it's needed, then it will come back in. Okay, so they will not keep all the data inside, only several data which are important to run. Okay, so inside the main memory, there is a hardware called overlay. Overlay is to make sure, is to locate where is this programs located. Okay, so if CPU needs a special program file, so it will go into overlay, which is inside the main memory. So when we say system memory, we mean main memory. Yeah? So overlay will locate where is it located. So these location here are all looking at your hard disk. Okay, are all looking at your hard disk. So programs are broken into several logical sections. So each program is broken into logical sections. So when the CPU needs specific file, the overlay will get these logical sections which are located inside the hardware to be processed by the CPU. A small portion of the program will remain in the main memory at all times, but other logical section would be loaded when necessary. Okay, so they would overlay. So this overlay section here is actually taking whatever necessary files to be loaded only. Okay, so this is the top of the file. Okay, so whenever it needs any other files, so this section will be cleared. So this overlay will go and locate for a specific file that you need and put it inside here. Once overlay, let's say for example, overlay 3 goes here. Once the hard disk, overlay 3 will be passed back to the hard disk, and maybe another overlay 2 or 1 will be transferred back. So this is how the computer system makes use of an overlay, because main memory size is not enough. Okay, so logical. So logical means, okay, logical means the CPU will generate an address. So, sebab dia nak file yang ada dalam hard disk. But file tu, the file is not inside the RAM. So what does the CPU do? CPU will come up with a logical address. This logical address will tell the overlay where is it located, what is it, where is it. Okay, so the concept of logical address space that is bound to separate physical address space is central to proper memory management. Okay, so saya ada lukis kat sini walaupun dia kurang jelas. Okay, so it's basically like this. Logical address generated by the CPU, also referred to virtual address. Physical address as seen by the memory unit. Okay, so this is CPU and this is your RAM. So all the files that needs to be processed will be inside your RAM. Tetapi ada juga file yang tak ada, yang duduk dalam hard disk. Nampak ni? Here. So when the CPU needs a specific file, okay, dia perlukan specific file, dia akan keluarkan a address which is called a logical address. So logical address ini akan masuk dalam RAM, and RAM will translate this logical address into physical address for it to locate the location of the particular file. Okay, so I repeat, yeah. So so CPU will generate logical address. So apa yang ada dalam logical address ni? Inside the logical address, it shows the location of that particular file that is needed by the CPU. Okay, so file tu masuk dalam RAM. So RAM will translate this file into something which is called a physical address. Okay, and this physical address is inside the hard disk. So question, kenapa kena tukar from logical to physical baru cari file? Tak boleh ke dia immediately bagi je physical address? No, it is not possible because of the hierarchy. Hierarchy dia ialah CPU at the top, bawah dia is RAM, and bawah sekali is your hard disk. So when you go from one hierarchy to another hierarchy, CPU cannot go straight into the hard disk because of the hierarchy, because of the difference between the memory space of the CPU and RAM and the hard disk. So it has to go step by step until it gets the location, until it gets a file. But do not worry, okay? This does not take time because it's very fast. So CPU will generate a logical address which is translated by the CPU, by the memory into physical memory. And where is this physical memory located? This physical memory is located inside your hard disk. Okay. So when I say logical address, it means an address. So address means it shows the location only. What is it inside there? We are not sure. Sama juga dengan physical address. Physical address just gives you the address of the place. What is stored inside there is a different story by itself. Okay, so as I was mentioning, the hierarchy. Okay, what does the hierarchy mean? The hierarchy means the closest memory to the CPU. The closest memory to the CPU is the smallest. Okay, so you have registers, which is inside the CPU. You have cache memory, which is inside the CPU. And then you have your primary memory, which is your RAM. And then you have your secondary memory, which is your hard disk. So this is the hierarchy. So if the memory system wants to move from one hierarchy to another hierarchy, it has to go through one after another. It cannot straight jump to, because of the speed difference, because of the size difference. What if we want to support programs that require more memory than what is available in the system? Let's say in a desperate condition, there is a need to have more primary memory. Okay? Because you want to process something big and you need a bigger RAM size. Okay? A primary memory. Yeah. So what the CPU will do is it will take some minimum space from the secondary memory and convert it into primary memory. That is called virtual memory. So virtual memory is basically taking a small size of the secondary memory or a small size of the hard disk and making it as if it's a primary memory. So why do we need to do this? Sometimes there is a need to keep more than what is needed inside the RAM. So that is why the computer system allows some parts of the secondary memory to become as if it's the primary memory, and this is called virtual memory. So virtual memory is basically a small portion of memory inside the secondary memory, which is actually a primary memory. Okay, that is virtual memory. So sometimes we can also pretend we had something bigger, which is called virtual memory. That means we pretend as if that the RAM size is bigger. Padahal it's the same size, cuma kita ambil sedikit bahagian from the hard disk. Okay, so registers is the closest, smallest, fastest to the CPU. Registers and cache are located inside the CPU. It's inside the CPU. Okay, and it is very, very fast because it's inside the CPU. It's next to the CPU, and that's why it's fast. And it can only take very, very short, very limited size only. Okay. So memory management. What is memory management basically? Is a process which subdividing memory to accommodate multiple processors. Okay, so process banyak. So now you have to divide the location of the memory. Which memory are we looking at? At the moment, we are looking at the primary. We are looking at the RAM size. So we want to divide the RAM size in equal or not equal sizes so that each location can have a maximum number of processes. But you have to remember, although there are more than one process, inside the memory, at any one point of time, there can only be one process running inside the CPU. Pada satu-satu masa, there can only be one process. So how is this done? Because of the speed of the computer, things are done very fast, so we have these processes will be interchanged with other process. So memory management is a process which subdividing memory to accommodate multiple processes. These processes will be done by memory manager. So there is another hardware. Memory needs to be allocated efficiently to pack as many processes into memory as possible. If only a few processes can be kept in the main memory, then much of the time all processors will be waiting to input output and CPU will be idle. Okay, if there's only a few processes, then whenever the CPU has nothing to do, let's say the CPU needs to wait for another input and output, then the CPU won't be doing anything because there's nothing else to do because they check dalam RAM or tak ada process. So what the system needs to do is it needs to maximize the RAM, put everything inside so that the CPU continuously has something to do. A process may be broken up into pieces, okay, because of the size of the memory, okay, which does not need to be located contiguously in the main memory. Contiguous means side by side. It can be any form, okay. So let's say we have process A. So process A can be divided into several sizes, and these sizes need not be side by side. We'll come to that diagram later. Okay. All right. So these are some examples, some readings that you can do. All right. So how do we divide the process? We can divide it in two forms. One is what we say is a contiguous allocation, side by side, contiguous, and another allocation is non-contiguous, bukannya bersebelahan. Okay, these are all happening inside your memory, yeah? So we can do it in a single partition, or we say as a multiple partition. All right, so this is contiguous allocation. So this is, okay, contiguous. This allocation is for a process. Okay, so when the operating system, when the PC starts, the top part of the RAM or the memory, main memory, is always located to the operating system files. These will always be here. Okay, so we say the low memory. Low memory ni kenapa dia low? Ini padahal it's on the top part. Okay, because of the address. Okay, of the address. Let's say this memory gambar ni ialah 100 kilobyte. So when you say 100 kilobytes, the address starts at 0 until 99. That's what this 100, eh? So you start from 0 until 99. So we say the low memory punya atas is always located to the operating system. And bahagian bawah ni is all given to the user program. So you can have all the user program, and all these are contiguous side by side. And if it's free, it's free. Yeah. Okay. So this is basically how the contiguous allocation looks like. Okay. So we can go for single partition. That means there's only one partition, all the files go there. Okay. Protection is done. So how do you protect each file? Because you kata ada satu partition je. Okay. So you are the limit lah kat situ. You are the limit kat situ. Okay. So this is basically yang ini pula is called multiple partition. So multiple partition is basically given to any number of process based on their size. Okay, so inside your RAM, you can allow more than one process, and you can have multiple processes. Okay, so partition ni dia punya size tu boleh berubah lah. Okay, so this is basically like this. So this is your memory, so you can have a few processes. Nampak ni, size dia berbeza. Okay, and then tiba-tiba process 8 ada. Where is process 8? Process 8 is already given to the CPU, has gone into the CPU. So a new process will come in, and the size is always there. Okay, so you can change it all the time. Okay, okay, so you can change the size. The operating system will change according to the size. Okay, so these partitions are fixed or can be dynamic. Dynamic means kalau size dia besar macam ni, boleh besar. Kalau size dia kecil, boleh kecil. This is dynamic. Ada juga yang multiple partition tapi size dia fixed. Okay, those were the older days whereby the memory size is always fixed. Okay, it's always fixed. Okay, so this is fixed partition. Right? Equal size partition, the olden days PC, meaning to say dalam inside your RAM size, everything is fixed. Everything is fixed. Okay, semua size dia sama je. So, let's say there is a process coming in. Proses ini size dia ialah, let's say P1. Okay, size dia ialah, let's say 16. Okay, so it will automatically get dual location. If the size is 17, so dia akan dapat 3 location walaupun only you need 17. So 3 location is 8 times 3 is 24. You only need 17 sebab 17 saja. Alright, so the balance is how many? 7. So this 7 is unutilized. This 7 is unutilized. So when it's unutilized, we say it's internal. The name for it is internal fragmentation. Ruangan kosong yang kat dalam yang tak digunakan. Internal fragmentation. F-R-A-G. Okay. Internal fragmentation is the empty space which is not being utilized. That only happens in the equal size partition. And then we moved on in about 1985, 1990, macam tu, we have unequal size. So unequal size is easy lah. Whatever the size of the partition, will be given lah. Let's say partition masuk at size 6, process masuk at 6, okay, ambil. And then 16, okay, ambil. But the only problem is, when you have an unequal size, let's say tiba-tiba proses 13, this 13 goes inside the CPU. So we have a balance of 13 kat sini. Kan? And then let's say along the way another process goes in. Proses 8 bawah ni. So total empty space is 24 kan? 13 plus 8 is 24. Alright? 24. Let's say there's a new process. PX with the size of 24. Boleh masuk ke tak? Okay, 24. Tak boleh masuk sebab there is no empty space. Because there is an empty space, betul, there is an empty space here and there is an empty space here. But proses ni tak boleh dipecahkan. But kalau kita gabungkan dua-dua ini, then we'll get an empty space. But now this is not an empty space. It's not side by side. It's two different locations. So these empty spaces in this category ni is what we say as a external fragmentation. External fragmentation. Ruangan kosong di luar. Yang ini pula yang tadi itu internal. So dia ruangan kosong di dalam. Okay, external is an outside. Okay, ruangan kosong yang outside. Okay, so that is why kalau you masih ingat lagi, kalau in your PC you selalu buat apa tu, defragmentation, right? So defragmentation is to rearrange all the files so that there is no empty spaces in between. Okay, so operating system, so dalam memory we have something which is called the external fragmentation. It's an empty space which is outside the partition. Okay, so you have equal size partition. Okay, so when we have equal size, meaning all the sizes are equal, and then you have there you see unused. So when it's unused, let's say process 1 comes in, it only requires maybe 2 megabyte. So the balance of it is unused, so we call it as internal fragmentation. It's an unused wasted size partition. Okay, and then like I explained to you, in an unequal size partition, okay, all the process will go in according to the size that it requested. Okay, and you can also have you can have a queue lah, the queues pula. Okay, so in a dynamic partition pula, okay, so dynamic partition macam saya kata tadi, dia masuklah whatever amount. Okay, dynamic partition dia masuklah whatever amount, mula-mula kosong, then masuklah proses 1, proses 2, proses 3, and so on so forth. Okay, so bila dah habis, dikeluarkan. Alright, so let's look at this example. So we have P1, P3, and then P4 masuk sini. Okay, where is P2? Mungkin P2 dalam memory. Okay, so eventually each process is blocked out. The OS swaps out process 1 to bring in again process 2, and another hole is 96 is created. Okay, so dia keluar masuk, tiba-tiba ada ruang kosong kat sini. This and this and this. These are all empty spaces, but they are not side by side. If there was a process which is bigger than 96, dia tak boleh masuk because there is no empty space for it. So what the operating system will do is it will do a process which is called compaction untuk cantumkan balik to join back all these empty spaces into one size, which is 96 plus 96 plus 64. Okay, because if you have an empty space in between here, sini and sini and sini, and let's say you have a new process coming in, process 5, size dia ialah lebih pada 96. So this process, P5, process 5 ni, cannot enter this one, cannot enter this one, cannot enter this one. So that's why it needs to do something which is called a compaction to rearrange all the empty location into one big location. Okay, so that is what it means by compaction. Right? So next we move on into first fit, best fit, because we have so many empty spaces. Example here. Let's say we have, let's look at graph diagram page here. Let's say we have this. Let's say we have a new process coming in. Size dia ialah 45. So where can it go? Where should it go? Should it go in the top, middle, or the bottom? Okay, top, middle, or bottom. Well, you can go in the top because it fits. Middle pun boleh, last one pun boleh. So which one do you do? So there are a few methods which are available by the operating system. It can use the first fit, best fit, next fit, worst fit. The first fit is the operating system will look for the first hole that is big enough. Ruangan kosong yang paling besar. So which is on the top lah. And then the next one dia akan cari ruangan kosong yang betul-betul just enough for it, the smallest. Okay, or maybe it will start from the next one. That means the last one ni kat mana, and then they start from situ. Or maybe the worst fit paling besar. Okay, so if we apply to this, let's say sebelum ini process, this process comes out. Ada file kat sini. Let's say this is PX kat sini. So kat sini PX dah keluar. In this diagram, PX dah keluar. Let's say there was a new process coming in, size dia ialah, okay, the size is, let's say the size is 60. Okay, so if we are using first fit, ruangan kosong yang paling besar dia jumpa, so is this one lah, this one. If we are using best fit, so we will search again ruangan kosong yang betul-betul ngam-ngam dengan dia. Okay, ngam-ngam dengan dia. So it will go from top to bottom. It will choose this one. Kenapa dia pilih yang ni? Sebab dia punya balance tu sikit. Kalau dia ambil ini, balance dia banyak. So this is best fit kat sini. Or next fit. Next fit ialah sebelum ni dia berhenti kat mana? Where did it stop? And they will continue from there. If it stop here, let's say here, then it will start from here. From here dia akan naik balik, dia akan check. Or worst fit, ruangan kosong yang paling besar, the biggest hole. So dia akan check from top to bottom. The first hole dia akan jumpa yang paling besar, dia berhenti, and this is the one. Okay, So there are four methods. First fit, the biggest. Best fit, smallest, or just nice. Next fit is from where it stopped to continue back again, and the worst fit is the largest hole or the largest space that is big enough. All right. So let's see some. Is there any question? Okay, there's no question. Okay. All right. Okay. So this is compaction. Okay. So when you have external fragmentation, the empty space which is outside, there are two methods of solving it. Like I explained to you, compaction. So you reshuffle balik, susun balik. All those empty spaces you gabungkan and you put it at the bottom, and all those space yang dah ada you put it at the top. That is one method. Another method dalam operating system is they do something which is called paging. Okay, paging means they will pecahkan file tu. Some of it will stay inside the memory and some of it will stay inside the hard disk. Okay, so this is how paging looks like. This is how compaction looks like. Nampak ni ruangan kosong sini and here. So when you do compaction, it becomes like this. All the empty spaces it will become like this. Okay, and paging, nampak ni. Okay, we will stop here and we will continue paging in the next class because this chapter is quite long. So I do not wish to rush, simply because there are a lot of things you need to understand. So we'll go slowly from this. Okay. All right. So let's stop here for today, and we will continue back in the next class. We will stop at paging. Okay. We will stop at paging at slide number 33. All right. Thank you very much. You have any questions you to ask me? Okay. If there's no questions, please sign your attendance. And inshallah, I'll see you in the next class. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Salam, sir. Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.